Are we on? Awesome. Thank you all for being here today to listen to us to talk about life cycle assessment for cloud hardware in particular. My name is Kari Leo. I'm from Microsoft. I'm here with Julie Sinistorio from WSP, as well as Hussam Alisa, also from Microsoft. And we're really excited to take you through this presentation today. I'm sure for many of you, this may be net new. For many of you, it's old. For others, you've probably heard all this 2 days talk about LCA or lifecycle assessment. And what we really want to try to do is give you a bit of an overview of what that is. So we're going to talk about what it is, what LCA is, why it's important, and then we're going to share a couple of lessons learned from some of the work that we've done at Microsoft in collaboration with WSP on lifecycle assessments. So again, I hope that you, by now, after 2 days, understand that Microsoft is really serious about sustainability. We take this very seriously. We have made some huge commitments starting back in 2020, well, starting back in 2012, but we really our leadership took a stance back in 2020 and said, we're going to be carbon negative by 2030, we're going to be zero waste, we're going to be water positive, and we're also going to care and figure out ecosystem goals associated with sustainability. So this is also why we want to use life cycle assessment to better understand the impact that our products and services has on the environment to drive towards these goals. So with that, I'm going to hand it over to Julie, who's going to talk us through what LCAs are.
Thank you very much, Kari. So what is LCA? Well, I've been doing this for 15 years, and I've tried to boil it down into one slide for you. So here you go, straight from my deck from UC Berkeley when I taught there as well. Life cycle assessment, where does it start? It starts with resources, the extraction of raw materials. We typically think of this like mining something out of the earth, but we actually extract materials from the air, like nitrogen, to make nitrogen fertilizer, and we extract it from the water, whether it's the water itself or fish or something out of the water. We take all of these extractions from the natural environment, and it starts to go through our product life cycle. So we turn raw materials like iron ore into an intermediate material like steel. And then we use that steel and we turn it into rebar and we make a building, right? Or we turn that aluminum into a housing for a piece of electronic equipment or something like that. So we've got all these materials coming together, intermediate manufacturing, all of the final manufacturing. We've got transportation and distribution all the way in between all of those steps to the use phase. And in the use phase, especially with electronics products, we've got the use of electricity to run our electronics products. But it's important to think of other things that get used up. So another example is with a car. You not only use gasoline to drive the car, you need windshield wipers and windshield wiper fluid and transmission oil and all these things that get used in the process of the use phase of a particular item. And then when the item has reached its end of useful life, it goes to its end of life. We hope as much of it is recycled, reused, recaptured as possible, but inevitably a lot of it ends up in a final disposal, like in a landfill or incineration. And all along every single step of that life cycle, there are emissions. Now, we typically think of emissions to the air, like out of a smokestack, like carbon dioxide or GHG emissions. But there are actually also emissions to the land, like deposition in a landfill, and to the water, emissions, emissions of industrial waste or something to bodies of water, something like that. What life cycle assessment does is we take all of these extractions and all of these emissions and we add them all up into a raw inventory, but then more usefully, we categorize them into the potential to cause actual environmental impact, such as energy demand, global warming or GHG emissions, ozone depletion, acidification, eutrophication, smog formation, water use, water consumption, water scarcity, and so on and so forth. Life cycle assessment, if you remember nothing else about what I said, life cycle assessment is not just carbon. It's a holistic approach. If you're only quantifying GHG emissions, you're actually not doing a life cycle assessment per the ISO standards. But I'll get off of my soapbox. So that's what life cycle assessment is. Now, another thing you may have heard of is this thing called GHG accounting, or scope 1, 2, and 3. This is related, but it is not the same thing. Let me say that again. This is related, but it is not the same thing. When you talk about scope 1, you're talking about your direct emissions. This is from things like burning natural gas to fire a boiler to create heat, or burning diesel to run a generator to create electricity right there on your site within an organization's owned operations. Scope 2 is all of the greenhouse gas emissions associated with purchased electricity. So you're buying electricity, therefore the grid is generating it using things like natural gas and coal and biomass and nuclear and all these other sorts of things. So the greenhouse gas emissions associated with that purchased electricity, that's scope 2. Scope 3 is pretty much everything else. It's a big category, but it includes things like the emissions from things in your supply chain, your purchased goods and services, your employees commuting, your business travel, any leased or other types of agreements about owning other types of operations, even financial types of agreements. That's all counted in scope 3. So you can see when building up to this, there are some overlaps in these two methods of accounting, life cycle assessment and GHG inventory, but they're not the same thing, okay? Not the same thing. Okay, so let's talk about how they're similar and how they're different. Let me orient you a little bit to this diagram. It's specific to the electronics and data center ecosystem, but it's intended to sort of illustrate those major life cycle phases that we were talking about. Raw materials at the top, use phase, end of life, right? Those are the LCA ones. And then we've got the different categories for scope 1, 2, and 3. That's the GHG accounting. So when we're talking about server manufacturing, we've got in life cycle assessment, we're talking about raw materials that are used to make things like semiconductors and transistors and thermistors and printed wiring board. That is the scope 1 and 2 of the server manufacturer. But when it comes to the cloud operations entity like Microsoft, that's actually their scope 3. When it comes to what happens to that thing at its use phase, that's the server manufacturer's scope 3. This is confusing. You see? I'm even getting confused. This is confusing. For the server manufacturer, the downstream scope 3 is the use of their sold product, the energy that gets used in the cloud data center. And then the downstream scope 3 for the server manufacturer is the product's end of life. Now, from the perspective of a hyperscaler like Microsoft, the materials production is actually their scope 3 upstream. The use phase is their scope 1 and 2. The end of life deposition is their scope 3 downstream. From the cloud customer's perspective, so the one that's purchasing the cloud services from Microsoft, the hardware manufacturing, that's scope 3 upstream. The use phase, that's scope 3 upstream. The hardware disposition, that's scope 3 upstream. And this all this becomes incredibly important when you're trying to think about who to apportion the carbon to, right? And who to apportion any kind of savings. If you realize some savings by reusing equipment or reducing energy, whose scope, where does that actually fall in? And how do you account for that? And life cycle assessment can inform many different aspects of this, but how you quantify in terms of a GHG inventory, you have to be very delicate and careful with and make sure you're putting it in the right category. If you're confused, you probably should be. This is confusing. This is legitimately confusing, and it's a hard thing to explain to, in a couple of minutes. But I wanted to touch on why different types of organizations do life cycle assessment. In this environment we're standing in right now, the piece of this pie that's popped out is designing for the environment. I most commonly see life cycle assessments get done in order to get, for one thing, to get a number, usually a carbon number, on that piece of equipment, whatever it is, a server, a chip, this little clicker, or this laptop, and to figure out what are the hot spots in the production of this thing, and how do we reduce it? How do we design this with the environment in mind? Another reason is they might want to make sustainability marketing claims. They might want to say, our thing reduces carbon in its production by X% compared to the way we used to make it, or compared to our competitor's thing. Or if you're talking about it in a larger infrastructure, an entire data center, we have been able to reduce the embodied carbon of our stuff by XYZ by doing this. You can use a life cycle assessment for that. It's also used for product environmental performance improvement. You can also use it to quantify circular economy reductions and savings. You can use it in greenhouse gas emission reporting. It's incredibly useful in scope 3, category 1 products, goods and services. for calculating that. And there are some standards out there, more so in Europe, less so in the United States, that using an LCA can help different pieces of technology comply with. So now that you know what LCA is and greenhouse gas accounting and that they are different, I'll hand it over to Hussam to talk about the cloud ecosystem.
Thanks, Julie. So one important part of when we want to do an LCA is to define the ecosystem that we want to work with. And since we're focused on data centers, servers, and cloud here, let's look at that spectrum. So we start from material production, where we're talking about the raw material extraction, whether it's material to build the chips, the servers, all the manufacturing and transport processes involved into building the servers, rack, supporting equipment, the material to build the data center walls that contain the hot or cutout containment aluminum panels, etc. And then we also have to think about the throughs, the replacement components, what may be required to replace components to the servers or redundancies at the data center air handlers. So there are all sorts of examples. Then we start thinking about the use phase. Obviously, we consume a lot of energy in the data center. We also use water on different fronts. So water is used to generate energy, go into the turbine, etc. And also we're using water to cool. So those are some examples where we are using water. Now, it's important to highlight from a definition perspective that we have a portion of water that's used in the cooling perspective or say the use phase, but there's a big chunk of water used in the manufacturing. When we're building coils or heat exchangers or servers, water is used there too. Could be a bit bigger portion than the cooling water. So that's important thing to think about. And then we can expand to end of life items, where we could be either talking about recycling the hardware or the equipment, or end of life methods that we could go, such as incineration, landfill, etc. And then there are the reuse opportunities affect the overall, let's call it GHG numbers, for example, because we might be using subtraction at the end of the day. Now, Julie showed you a list of impacts, or we can even think about them as the environmental burdens, those 9 of them or so. We could also refer to them as the environmental impacts, or that we would like to look at when we're doing any LCA or any life cycle assessment. In this slide, we're showing typical usual suspects that we look at in the cloud industry, which is GHG, energy consumption, and blue water consumption. Now, again, those 3 items are related to or kind of the typical items, but you might be looking at different environmental impacts depending on where you're deploying the data center, or maybe in a different industry, you'll be interested in other burdens or environmental burdens. Another element of when doing the LCA is we could actually run different sensitivity or parametric analyses. For example, the impact of technology route A versus technology route B. We can look at the impact of different manufacturing processes for DIMMs, for example. So this doing parametric studies could be also a crucial part of doing LCAs. Another very important item to understand when running LCAs is the functional unit. And that is the unit used to normalize the findings. So each industry has, let's call it an ultimate product, or the normalizing factor or denominator that could even be used in TCOs. So in LCAs, we need such a unit because we will be able to compare different cases normalized using the functional unit. Example, when we're talking energy, we could be thinking about energy generation, the grid, the renewables, etc. And we want to do an LCA oriented around energy. One could say, well, you could use megajoules as your functional unit, and then your environmental impacts would be normalized by your megajoule count. Let's take it to the data center. So if we're talking about the building, the land, the supporting equipment, etc., You could say the data center's function is to deliver megawatt of IT capacity, and hence megawatt of IT capacity could be used as a functional unit. Expanding to servers, so we're talking about the chassis with the DIMMs and the flash and the hard disk drive, all the stuff inside the server. We could use the server itself as a functional unit, or we could actually use the physical cores. And we could combine all these things together if, for example, looking at the whole stack or the whole cloud ecosystem. At the end of the day, we're selling, or the product is VMs. And you could see there is this analogy with TCO models. So we could use the virtual machines as our functional unit. And with that, back to Kari for some examples.
Yeah, just a couple of examples, and in the interest of time, we'll move really quickly through these, but here's just an example of what Hussam walked through. And so when we're looking at the life cycle of a server and trying to assess that, we start with identifying, we pick the server that we want to do the LCA for. We then have to figure out, okay, what are the suppliers? Where was this manufactured? And we have to backtrack that. And that's really one of the huge challenges. And when you start looking at LCAs, to get all that data collected, and one is to find it, but also get it collected and then have it analyzed. Just ask Julie how much work that is. So we start looking at the raw materials. Which raw materials does it contain? We'd have to look at the BOM. We assess all of that. Where was it manufactured? Then we look at the manufacturing piece, what energy went in, which grid was used to actually manufacture a given component. We then move on. You all know how server racks are manufactured. There's a whole bunch of tier 5, 4, 3, 2, 1. There's a lot of pieces. And in between, you see the transportation needs to be factored in. We then come to assembly, integration, testing. Sometimes it happens in the same place. Sometimes it happens in another place. Then move on to use phase, as well as end of life. So all this data has to be coming together and collected before we can get any kind of results. Here's an example result. It's an example, but it's also directionally pretty correct. And I always refuse to talk about accuracy in LCA, and we'll talk about that very shortly. But you can kind of see here, we look at the impacts across GWP, blue water consumption, fossil resource scarcity, et cetera, a bunch of different elements. And then we see, okay, where are the hot spots, right? If you can glean from this pretty quickly, but you can also get this later. I mean, the ICs, the major chips, the SSDs, the CPUs, and the memory modules, if you look at a server, look at a rack, that is really where your carbon sits, in the manufacturing space. So just a quick comment to thinking about LCA. People want to get the number, and then they want to compare it. Be very careful with that, because we've done some LCAs internally, and we've picked the same thing, and we have done it in a way that is conformant or aligned with the standard that is there for LCA, and the results are not identical, because it all depends on what data sources do you have, what methods do you use, and there are multiple methods out there that are okay to use. And so it's just kind of something to keep in mind, and something for us all as we move forward to find standards and find ways to communicate these results, that we always have to be aware that comparing numbers should be done with care, and we always need to look at the assumptions. And I think what we really need to drive towards is directionality, like where are the hotspots, and then start drilling down deeper into those. And we really want you all to start doing LCA. So Hussam, do you want to talk a little bit about kind of...
Just high level, because we're almost out of time. But we learned a lot of lessons when we did LCAs. Just on a high level, you really need to define the goals of the LCAs, the audience. And you could have LCAs where you're looking at your current fleet and current products, versus you might be looking at future technologies. And those LCAs could be either used to influence executive decisions, external company PR policy, or even engineering teams. And just going through the LCA, there are a lot of things that's very important to learn about early on, and that's why there's an SOP document that we drafted. Kari will talk about how to best start an LCA.
Yeah, no, thank you for that. And again, I think we've touched on some of these things. We'd love to also hear from you all. Come back and talk to us after if you've done LCAs and kind of are running into the same challenges. Accurate data is hard to find. And current data is really hard to find for our industry. You look at the informational technology node that's available, it is 10 years old. We know the technologies that have the evolution, the really fast changes that have happened in that. It's not very reflective. So we need to work together to be able to have access to that, so we can drive towards more accuracy. It's also a lot of work in a big company to get all the right people involved. So that's another thing, you start this. But I'm not trying to discourage you from doing it. I'm just giving you a heads up that there's going to be a lot of people you need to have involved. You can read through the rest. We really encourage you all to do LCAs, especially at a product level or at a design level or a system level. You have a thing, you're designing a new thing. Try to understand the footprint of that so that you know if you're driving in the right direction or not from a sustainability perspective. There's two things that's been mentioned before. There are 2 work streams in OCP for sustainability. We really want more companies and more doers, more people to lean in and drive the work there. People have asked for that before. But the last thing, a contribution that we really want to make to this community is, as Hussam mentioned, it's a lifecycle assessment cloud guidance white paper, and it's kind of, we call it an SOP as well as standard operating procedure on what are the things you got to think about, what are the steps. And so that will be available on the OCP website in a couple of weeks, and we really hope that you can use that, you can improve on it, you can share your input, and that we can continue to collaborate and eventually also share our learnings on lifecycle assessment. So I think with that, we're at time. I just want to thank Hussam and Julie, and thank you all for attending.